So I've written the first 6 so far, and these are all free response, and then the rest of them on this exam were multiple choice. So, as I had said earlier, the stuff that I wrote in blue, well, with the exception of this plane here, was given, and what I've written in red, or what I've written in black, that's not given. I just have noted that for importance for each question. So, we'll start with this one over here. We want to find the equation of a plane that contains this line, and I've drawn this line right here. And the plane has to also be parallel to that line right there. So this is the vector equation of a line, and then that's just the vector equation of a line. And what it means for a line parallel to a plane is that if I physically had the plane and I could like pull it out of the picture, and I could pull this line out, I could grab the line and place it directly on the plane without having to angle it at all. I could just translate it and place it right on the plane. That's what it would mean for a line being parallel to a plane. So I can just place it right on the plane. So, okay, so we need a plane that contains that and is parallel to that. So, to get the equation of a plane, we need a point on the plane as well as a normal vector for the plane. But we can actually get the normal vector pretty easily by just taking the displacement vectors, or the directional vectors of each of these lines. And then if I were to just move that one over here, both of those directional vectors I could then just place on the plane, and if I were to cross the two of them, I would get a normal vector for the plane. Does everyone see what I've said? Yes?
So basically, you just cross the two vectors of the lines.
You'll cross the directional vectors.
Yeah, like the two that compose of the lines.
Yes.
Yeah.
Okay. So, does everyone see this would be the directional vector of this line? Because this is, you have x minus x naught over a equals y minus y naught over b over c. You can see a, b, c, where this would be
Doesn't depend on
x, y, z equals x naught, y naught, z naught, t plus t times a, b, c. So everyone sees this is the directional vector for this. Okay, so we'll just go ahead and cross the two of those. So just arbitrarily, we'll take this one first, 0, 2, 2, and we will cross it with 4 minus 3 and 5. I got 16, 8 minus 8. Yes.
Why don't you just use n as the normal vector of the plane parallel, like the x minus 2 over 4 symmetric equations? Is it saying that the plane?
That's because a line doesn't have normal vector.
Well, I'm saying, but is it saying that the plane is parallel to that, or that line is parallel to it?
The lines.
Those are the same thing. Those are the same thing. A plane being parallel to a line would be the same thing as a line being parallel to a plane.
No, I mean, is it saying that the line is the line is?
Are you talking about this line?
Yes, and the other line as well. Is it saying that it's parallel to that line or to the plane itself?
So the plane contains this line,
Yeah.
and any line that is on a plane, that line is parallel to a plane. So all lines on a plane are parallel to the plane, but not all parallel lines to a plane can be placed on the plane.
The first line is contained within.
So this line
The second line is parallel.
is on the plane, which means that if you were to plug the x, y, and z equations of that line into the equation of the plane and perform this dot product, you would have to get 0 because it would have to satisfy the equation of the plane since it actually exists on the plane. But this line, since it's just parallel to it, if you were to plug it into here, you might not necessarily get 0. Does that answer your question?
Yeah.
Yes.
Is j supposed to be 8 or -8?
Let's see.
16
Minus 0 times 5 minus 4 times 2. So you'd have
A minus and
0
-8.
minus 8 and then a minus.
Oh,
You have
okay.
2 minuses and you
Alright.
get
Sorry.
positive 8.
Sorry.
Does order matter, or in this case?
You mean for crossing this movie?
Yeah.
No.
Okay, so you could get -16.
Yes, right. So in this case, let's suppose that that vector is 16, 8, minus 8. If you were to cross it in the other way, you would just get the same thing, but it would point the other way. But it would still act as a normal vector, right? Because like if I have, this is the plane and this is the first normal vector I got. If you cross them in the other way, you would just get this.
Yep.
And it would still act as a normal vector. Okay. Other questions?
This is the normal vector?
Yes.
This is a normal vector, yeah.
One of two.
One of many. If I were to multiply this by any number A, where A is a real number but not equal to 0, it would still act as a normal vector because you could just stretch it. Yeah. So this is just a normal vector, one of many normal vectors, but it's one nonetheless. So we're going to use it because it will satisfy this part of the equation. So now we just need this R naught. So we've got this guy. Now we need the R naught. So we just need a point that is on the plane. But fortunately, this line's on the plane, so 3, 0, minus 2 is also on the plane, because if you plug in t equals 0, you get 3, 0, minus 2, which is a point on this line. The line's on the plane, so that point's on the plane. So we will just go ahead and select 3, 0, minus 2 to be R naught. We'll just write that. So use R naught to be 3, 0, minus 2. So now we have everything we need. So we found n was 16, 8, minus 8, so we can write that. And if we just go ahead and evaluate this, we would get this. So are there any questions about the first one? The process all made sense? So we started by taking the directional vectors of each of these lines and then crossing them to get the normal vector for the plane. And then we just selected 3, 0, minus 2 as a point that is on the plane, because that line we know lives on the plane. Is this okay with everybody? Question? We have to approximate this interesting value here by linear approximation. So we learned not too long ago that if we have some surface in R3, that we can approximate values on the surface near a certain known point on the surface by introducing a linear approximation, which is essentially a tangent plane to the surface at that point, such that in a small neighborhood of points nearby that point on that surface, that tangent plane very closely approximates the values of those points on the actual surface. And the formula for that is given by L of xy equals some known value or known height on this surface, which in this case we're assuming that the surface is given by some function of x, y, as opposed to like a parametrically represented surface R of u, v, because we did also talk about that. But in this case, assuming it's a function of x, y, and if it is, we can create this tangent plane, which acts as a linear approximation by this formula here, which when you expand that, you get the formula that we talked about in class, which is this one here, where x naught, y naught is an easy value. But easy, and we know the exact value of it if we plug it into f. So here we're told f is going to be that function there. So we'll figure out what f of x naught, y naught is. Then we'll take the parcels of f with respect to x and y, evaluate them at that node point, and then plug in the ugly values of x and y into x and y there, and then subtract the simpler values of x naught, y naught, and then just plug everything in and then simplify it, and we have the answer. So we'll have, if f of x, y is given by that, then f of x naught, y naught. Well, first we have to figure out what x naught and y naught would be. So you'll notice that 4.003 is really, really close to 4. So it would probably make sense to use x naught equals 4 for that. So everyone sees that? And likewise, 1.998 is really close to 2. So we use 2 for y naught. So if we do that and then plug this in there, we will get 4 squared over 2 cubed. So it'll be 16 over 8, which is 2. And now we'll find f sub x and f sub y. And now we evaluate it at x naught, y naught. Wait, let me. Just want to do this. So I got -3. Okay, so everything we need, so now we'll just plug everything in. So instead of L of x, y, we'll now have L of that number, comma that number. we get that it's approximately equal to that. Yes?
Is there like a general equation that they might ask for? Is, like, I remember there was like some problems where they just asked for the equation. Would you just give like the final equation without solving it for like a specific point?
How do you mean without plugging in like X naught, Y naught?
Yeah.
I mean, I guess you could do that, but it would just be less steps than this.
Okay.
Yeah. I mean, if you know how to do this, that'll be simple. Yeah. Other questions?
I don't know.
Yeah.
Wait, so, real quick,
Yeah.
you have, with F sub, with F of Y, when you're taking that, you have, what's this? Oh, are you, I can't remember, are you taking, no, wait, you have X and then you have -3 Y to the -4, why do you have like, why do you have 4 there? Or am I missing something, am I just forgetting that that's a derivative?
Which
Yes.
four
Oh, I'm just forgetting that's a derivative.
And that guy is the derivative of y to the -3.
Got it, yeah.
I rewrote the function like this because I didn't want to make like a stupid error
Mhm.
when looking at this y cubed down here and trying to figure out in my head, okay, so that's y to the -3, -3y to
Yeah,
the,
yeah, yeah.
that's 2 steps, so I wanted to write out both steps.
Okay,
So
awesome.
that you don't get confused as well as, so that I don't get confused. Questions? No. Hopefully this was clear. I'm trying to like deliberately do like a bit higher quality explanations since this is the final exam review. You'll notice this is all a bit neater than it usually is. So I wanted to give you something special, the absolute best quality I possibly can for the last review of the semester.
Thank you, Owen.
What?
Wish we could have gotten the exam last semester.
Alright, anyway, is it okay if I move this up and bring down the next?
Yeah.
That's coming later.
Is this a value?
Alright, so,
Why is it always set up always in our tools? I met a kid in the other class who showed me practice exams. They had to set up 5 integrals and didn't have to solve a single one.
anyway. Next question here, we have to use the Lagrange multipliers to find the absolute min of this function here. Subject to the constraint, the sum of xy squared equals 32. So we'll use the Lagrange multipliers, which says we take the gradient of f and set it equal to a lambda multiple times the gradient of g. So when you expand that, you'll get this. So you will have, well, let's see what f sub x is. So if f is equal to xy, then f sub x will get y, and f sub y will get x. Equal to lambda, g sub x is going to be 2x, and then g sub y will be 2y. Alright, so this will give us 2 equations. Of y equals lambda 2x, and x equals lambda 2y. And I'll just label each of those equations. So those are equations 1 and 2. Okay, so first we'll just turn our attention towards the first one. So y equals lambda 2x.
X equals, yeah,
Okay, so you'll notice that if you were to take this equation and divide it by the second one, which I think is actually probably a smarter thing to do, we'll have y over x is equal to x over y. So everyone see how I got that? So y over x equals x over y.
Oh.
The 2 and the lambdas will cancel.
Damn. Then I get x squared like that.
Yeah, so if you do that, you get x squared equals y squared. And you might be thinking, okay, well, what do I do with that? Well, you'll see that that works quite nicely with this constraint, because if x squared is y squared, then you just have 2x squared or 2y squared equals 32. So then you know x, so then you know y, because then x, you just plug it back in here. So if x squared is equal to y squared, which is just coming from up there, then x squared plus y squared equals 32 implies that 2x squared, or conversely 2y squared, is equal to 32. Does everyone see how I did that? I just plugged in x squared for y squared into this equation and then simplified and got this. So there's no confusion? Is that how I did that? Okay, so if that's the case, then x would have to just be equal to plus or minus 4. Because you'd have plus or minus 4 squared, you'll have 16. Multiply it by 2 and you'll get 32. But since y squared is equal to x squared, y is equal to plus or minus what x is equal to, which is equal to plus or minus 4. Yes?
So there's two absolute minimums in this.
This gives us a set of 4 points. Minus 4, minus 4, 4, minus 4,
But I
minus
mean-
4, 4, and 4, 4.
Yeah, but like there's 2 for each. Because yes.
Oh, are you saying that you plugged it in?
Yeah.
Oh, I haven't thought about what the values are.
Okay.
I'm gonna plug it in.
Yeah.
I mean, again, I don't know in advance,
Yeah,
like what
yeah.
the, there might be 2, we'll see. So, so we have x, y in conclusion is equal to plus or minus 4, plus or minus 4, which is the same thing as minus 4, minus 4, 4 minus 4,
Misread
minus
something, so
4,
I have to rewrite it.
and 4, 4. So now we'll plug in all of those points into f and figure out which ones are the smallest, and those will be the absolute minimums. And since f is equal to x times y, you will notice that 2 minuses will make a positive, so we won't look at that. 2 positives is obviously positive, but 1 minus and 1 positive, the product of those will be negative. So you'll see that if we were to take f of plus or minus 4, minus or plus 4, which just means that they have to be different signs, you'll get negative 16, which is the absolute minimum. Yes?
What if like, cause I remember when we did this before, we always did we checked where the first derivative equals 0 to make sure that like the min didn't end up being like something we could find off of it. You know what I'm saying?
Well, it's a plan here, so.
I mean, there are some ways that you could do it a bit faster.
I don't know, that's pretty fast.
Would you guys like to see the faster way to do it? But you're not gonna get points.
Faster than this?
You won't get points, but you can use it to check your answer, sort of.
Faster than this?
Well, it's because it's a plane that makes it.
Yeah. So essentially, you can argue that because g of xy equals g of yx, and f of xy equals f of yx, that the minimums and maximums will occur when x and y are either the same or opposite signs, which would reduce this to a single variable function, 2x squared equals 32, and f of xy equals x squared, which would give you the maximum, and f of xy equals negative squared, which would give you negative x squared, which would give you the minimum, and solve it in like 2 steps. But anyway, don't do that because you won't get points.
I do remember what he was talking about though, with something about the finding where like the
You
gradient
just check the
equals
first
0.
derivative. Because if it wasn't this clean, like, and you take the first derivative, you could get like -1 or 1. Like, if these weren't the values, and then that would happen to be lower than whatever you found through the multiplier.
So there's also another way you could do it. You could go to polar coordinates, x equals r cosine, y equals r sine. And then you obtain the radius, and then you solve for the theta, and then plug that into here. And then take the derivative with respect to theta, set it equal to 0. You'll get the angle that maximizes. Plug it back in, you'll get the mins and max.
That sounds awful.
Yeah. Anyway,
Wait, so R squared equals 32.
this is
They said it would be either like 15 or 16.
there are 15 on this one, so it'll probably be about
Oh, it said 15 tree responses on this one.
no 15 total.
15 total, bro, it's gonna be like half and half. All these things are half and half.
Yes.
What are the odds you think we're gonna get one where like we have to check like the edges of the region?
That's annoying.
We haven't done that. in a
Oh, you mean like you have like a rectangle?
Yeah, or like a triangle, and you have to check.
That's a good one.
We haven't done that in a minute, and I low-key don't remember at all how to do that.
I'll see if that's one of the future questions.
Yeah, you have to
Okay.
make up.
If not, I might do it at the end.
If it's a rectangle, we can check
Anyway.
each length. And
Question 4.
plug in
We have these bounded by those 4 lines.
one in terms of the other.
So we have to set up this double integral after we do the change of variables to the UV plane.
0, 2, just
So,
2, 4.
because our region is a polygon, we just need to find the vertices of it, and then find the vertices in the new region, and then connect the dots, or connect the lines, and then we'll have our new region. So, we'll find when all of these lines equal each other. So, I'll just label each of them. Okay, so first we'll do 1 equals 2. So those actually don't intersect. We won't do that.
I was about to say
Let's do something
they're
else.
parallel.
I almost wrote the equation. Okay.
Same slope, different
1
intercepts.
equals 3. 1 equals 3. You would get 2 equals minus 3, which wouldn't be true. So
Wait, 1 equals 3.
Oh, that's
Line 1 equals
equation
line
1
3.
equals equation 3. I labeled the equation. So we'll have the x equation equals the y equation. So we'll have 3x plus 2 equals minus a third x plus a third.
Oh, and
Okay, so I think I'll be a bit quick here. So you'll have 10 thirds x is equal
plug in the change of
to
variables.
minus 5 thirds. So x is equal to minus a half. Someone check to see if that's correct.
Owen,
We're not-
Owen, can you just plug in the change of variables?
Yeah, I did it completely different. So like, you see how u equals 3x minus y and v equals x plus 3y? So you know that u and v are equal to, you can manipulate every single equation over there to get 3x minus y and to get, so for 1, it's y equals 3x plus 2. If you do minus 2 and then minus y, negative 2 equals 3x minus y, which also equals u. So then you know that's the lower bound.
Oh, shoot.
Is u equals minus 2.
Yeah.
I guess I
And you
didn't-
can finesse it that way.
I didn't think that this change of variables would be like so controlling.
No.
Right?
You
No,
literally
no,
just,
they
like,
will
you just
definitely
manipulate
work
all
to
of
get
them,
us some
and
points.
then all of it's
I
gonna
hope.
be equal either u or v, and then you'll get your bounds like that.
Alright, yeah, let's do it. Let's try doing it this way. Alright, so taking a look at the first one, which is y equals 3x plus 2.
This is what he makes it easy for his students.
That is equivalent to negative 2 equals 3x minus y, which is, you'll see, is equal to u. God, that's so stupid.
So the lower bound is negative 2. But these are the kinds of questions bro asks. Like,
Okay. This is a much smarter way to do it. Alright, so see what are we gonna do for second one?
you subtract y and then add 3 both sides. Then that'll be
You get
because
It's
it's
gonna be
y
wait,
xu on the top.
or it's
You go
X
from
and
y
two
equals
to 3.
3x minus 3. We do the exact same thing we did here. Go from
Yeah.
Yep, 3 is equal.
No, you get UU.
Minus 3 equals 3x minus y, which is equal to
Plus
Positive.
3, plus
Positive.
It's like you cross. You get the same answer if
Plus
you cross
right, so
XU, XV, cross YU, YU.
Yeah, okay, it's 3, and yeah, we just keep doing this.
And then 3 multiply everything by 3.
Yes.
3y
I
minus
believe so,
3y equals 1 minus x.
just 1 over that, but I just have to.
Oh yeah, let's multiply it by 3 first. Well, I'll write it first, so.
Dude, the other class is so free. I met a kid, they didn't have to solve a single integral in their third exam.
That's correct. Not a single one.
Not a
What?
single.
Why?
I kid you not. He showed me. It said set up and do not solve for 6 straight problems, or like it was 5 straight problems. It was like 6, 7, 8, 9, and 10. We're just straight set up and don't solve. Our final is gonna be probably very similar to that. I doubt we're gonna have to solve very much.
That's crazy.
Yeah,
I'm so dude. The questions he asks are like north is the y direction, east is the x direction. When the guy looks to the east, the hill goes downhill. When he
that was
looks
the
to
wrong
the
side.
north, it goes uphill. What does that tell you about the first derivative with respect to x and y, like partials?
Seriously?
I kid you not. I
You know what? Okay.
Completely different landscape here.
That's crazy.
Completely different landscape.
That's
Luckily, he's
insane.
making the final.
I don't think he's gonna fuck us though.
Dude, if Muscaderi wrote the finals, and names his class to be cooked.
It's massive.
His exams are, bro.
So Muscaderi's exams are harder. Like
Way,
To be fair,
way.
he tries
Their
to
first
do
exams are
every
so
kid.
fucking
Yeah.
Like,
Well, they also did like 2-3 weeks before us.
They go fast.
yeah,
Yeah,
but they
'cause
go
it's like
fast and then they
class-
don't do anything. Like, their exams aren't, bro. It's not the same.
From what I've heard about how Naines teaches, it's a read the book and we'll talk about it.
Bro, I'd rather have that and free exams.
Oh, this one's gonna wait.
I'd rather know what I'm doing.
That's fair.
We only know it. We
For
only
what,
feel like
like,
it's
it's
free because
we'll
we
need
learned
I
about
don't
it like
learn
we'll need
math
this
by
for
reading a
physics.
textbook. Like, that's my
And
biggest
like,
issue.
we'll need this for our classes.
We're going to.
Alright, so now we have
This
the
conceptual
bounds.
stuff is better. For that. Oh crap! I still have to do this. 3. You got 3 tenths. You got 3 eighths.
Actually, I think it's 0 over
I might have done something wrong.
over b second. 1 to 12.
I might be. I might go
Equals
see.
the Jacobian.
I have to stop calling that so stupid when I do this
Damn, I forgot about that.
That's really not true.
Because
They
we're
forget
doing
that
that shit all the time.
Because we're doing
Alright, so
change
we got the
variables.
bounds.
I got some
And,
balls.
oh yeah, now we need to do the Jacobian. So we can do the trick.
1 over.
Yeah, we can do the trick.
Oh, 1 over that. Oh.
du
It's just
dx.
Nice one.
I just want to get this class over with.
Oh, yeah, I'm just gonna convert from this.
Oh yeah, that's right. That's right.
You need to do that if you know that.
Completely
Think
forgot
we're
about
ever
that.
gonna use the gentleman's theorem?
It's not good at that.
I forgot about that trick. The gentleman's theorem?
Yes.
Is that Jacobian?
The French gentleman.
Oh,
French
French
guy.
Rose.
Dude, I have to take French guy.
French dude.
Dude, I would join
You made things much simpler.
I have final take right after this one. Where are you going?
Dude, I don't even know. Maybe my mom's gonna pick up for me.
Yeah, that's crazy.
I need
I just did not find
Yeah,
that.
So not 5.
As long as I do well in school, she really doesn't.
It's 1/10. Okay. So it's
Alright, so now we just plug everything in.
1,
Well.
12, -2.
That's why I was in my mom doesn't know that bad. That's crazy.
That's D.
I don't know 12 over 4. I mean, I don't know. Because I don't lie. So, like, if I do that.
Yeah,
This might be a stupid question, but
there's no super questions.
You troll people all the time. What the fuck is you talking about?
is there ever a chance, like, if the bounds are gonna be flipped, you know what I'm saying? Like, this is du db.
It's a free response question.
If we flip it, it's fine.
It
Well,
doesn't
I mean,
matter.
it wouldn't.
And look, you just
Yeah, the bounds are all numbers, so.
Oh, I see what you're saying,
Yeah,
okay.
And it's
by Mr. Fabini, you can just swap them.
Mr. Fabini.
That's his name?
that guy's
Yeah.
Fabini's theorem.
He's a real one. He's a real one.
Either one. Yeah.
No, that's Claro.
Claro is the one with the derivatives.
Yeah, Claro is the second derivative.
Partial and.
I'm impressed.
Oh, we just set it up?
I don't know. Yeah, we just
It just says
Oh,
set up.
that's real.
It doesn't even say solve. Wait, yeah, it does say
Is
solve.
what?
Is 1/10 supposed to be their choice?
That's a period.
Oh, okay, sorry.
Yeah.
Period in math.
You said that and I thought it
So
was
it's just
okay.
I see that it's.
Look.
at the top.
Great. That's not a sentence. What can be fucking great,
Okay.
bro?
I was gonna say grammar in math
Oh,
is
wait.
so little.
comma.
Owen, your
Wait.
1 less than equal to b
I
less
thought
than
you used
equal
like
to 12
boxes for
big
periods.
period
in that.
versus your 1/10
QED.
tiny period.
Maybe,
Yeah.
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 You're
And
inconsistent,
then that,
man.
and then the tiny period.
That's
1/10.
better.
That period there looks more like your
That's
multiplication
like
than
the
your
next
period.
Consistency is only a virtue if you're
I
not
mean, hey,
screwing
look, period?
Yeah, that's true. That's true.
Ethan,
All
you
big.
waits for like
All
half a
big.
minute
the whole
to-
time.
Big.
Yeah.
Exactly.
That's what I thought he was like trying to do.
I've been doing this whole time.
I'll have to remember that thing for the Jacobi.
You take that.
Yeah, that's helpful. It saves so much work.
This is like otherwise I was gonna. Alright, what's X? What's
Right, and then you take a thing of that, and it's like weird.
Alright, bro, not bad.
Oh shoot!
Do you hope he's the finals?
Yes.
That's why. That should be positive. I mean, it's positive 9, so it's gonna be 10 over 10 over 1.
Alright. Using Stokes' theorem, divided with this guy here. Abby, you check to see if it's actually
I would just
possible
ignore
to do
the
that.
exams
Hopefully it is.
I didn't. I looked at those yesterday.
And our surface looks like it's a hemisphere,
I did.
which is a fancy word for half of the sphere.
That's true.
Because we love to sound super sophisticated. So.
Like, I say leftovers. That's it. That's on the page.
Alright, so we have a hemisphere here. And yeah, we're gonna be using Stokes' theorem. And yeah, S is this surface here, and we have outward unit normal vectors going all around the place. And Stokes' theorem says that if we take the double integral of the curl of f over that region, over the surface, that's the same thing as the line integral of f dot dr around the boundary, which is going to be, okay, so since we have upward unit normal vectors, we would have to be going the positive direction, which is counterclockwise. So we would take the line integral around the boundary, and the boundary would be given by
That's just 4 cosine.
r of t is equal to 2 cosine t, 2 sine t.
Damn it, so close. It's 2, no.
You just need the boundary, we have a circle of radius 2.
Okay. Damn. Can you do Z as well?
Wait, hold on.
Yeah, you're right.
No, because he's doing a circle
No, I
for our
would
2.
Wait.
Isn't it just one?
Right. Z is
Z zero.
Let's figure this out like Jackman. So, well, 0
That's it.
equals this guy here.
Yeah.
Yeah, square both sides,
Square
add
both
the
sides.
variables over, divide by 4, it's radius 1.
Oh shoot, you're right, it's just 1.
Isn't the answer just zero anyways?
Yeah.
Because when you dot f, z is 0.
So you get r squared, what's called,
No.
Oh wait, yeah, I see what you're saying.
It's because when you have to do
Yeah.
f dot dr, because z is 0, then when you dot that, you plug in z equals to 0.
Alright, so since we're evaluating this vector field just along that circle, which is at z equals 0, since there's a z there and there, the I and j components are 0.
That's all.
And then the k component is 0.
Yeah, so we have x
Essentially
equals
r
y
squared.
squared k.
Oh my god, this is 0.
which is equal to r squared.
But our parameterization has no z component, so if you dot the two,
It would be
yeah,
zero.
you get zero.
So it's just zero.
Does everyone see that? Or should I write it out?
Can you write it out, please?
Yeah,
I'd say because r.
Alright, so,
But you don't even parameterize that R, just think of. Cause when you do that DR.
oh, I have to write our prime
Because
here
you're in
actually.
3D, you have to have a k component for your r value, but it's 0 since z.
I'm saying like you
Zero
do your
prime.
parameterization, it's just cosine theta, sine theta, 0. There's no R.
Oh, I
Because it's
see.
only a
Yeah,
single integral. So you can only
F is
integrate
gonna
over
be
one
0, 0,
variable.
Minus 0 cosine theta.
0, 0,
Minus 0 sine theta plus 0 cosine theta.
No, 4.
Plus 0 times 1.
4. And then
Hypothetical.
started with
All that stuff is making sure that
negative
you can
sine
have one or two parameters to use.
I just default to the drdt dt. When I see
Gotcha.
.dr, I
No,
default to
but
dr.
that's what I'm saying, with this, we know that you can only have one.
So since x and y are cosine and sine of t, if you plug them into f, you'll just get cosine squared plus sine squared k, which is just 1k. And the x and y components are 0, you get z 0. So if you take the dot product of
remember
these,
r is
you'll
equal to
see
1.
that you just get 0. So that means that this is going to be equal to 0.
Oh, I see the math.
Does everyone see that?
Yeah.
Yes.
On the quiz we did on Monday, there was a problem where it was a hemisphere, but it was like tilted. So you have those. Do you think it's easier to just make up a parameterization for the line, or like simplify it using like Green's theorem?
Wait, if it's angled, you have to use Stokes' theorem. But, I guess that would depend on how complicated the vector field is. If it's a really complicated vector field, yeah, it'll depend. It'll greatly depend on what you're given. Yes. Is that a question?
Oh.
Yes.
Is that ds or capital S ds? But not capital M bold.
What do you mean?
Is the ds a vector?
Yes, well, yeah, there's a dot product.
But it's
Stop,
the,
bro, come on.
it's the vertical one.
Yes, so
He's laughing right now. He's so bad.
Alright.
So what are you doing? Come on, bro.
It's in the
sorry.
It's in the transition from the double integral to the line integral that makes the z component 0, right? Because it's just the circle.
Yeah, okay.
It's just the
So instead of above z.
Other question, you just know z equals 0 because it's the.
No.
Well, because
Six.
that's how you
They
parameterize
just-
it. You want to parameterize it so that you can have it.
Alright, so.
Like your
Okay, so for this one,
just
we're using the divergence theorem. So we have our region is a prism, and it's given by those. So we'll just go ahead and, just for reference, we'll just do a drawing of it. So we have x equals 0, which in the context of R3 that's a plane. So this is x, this is y, this is z. X equals 0 would be, you can think of it as like the zy wall. Y equals 0 would just be the xz wall, and z equals 0 would just be the floor. So essentially, we're in the first octant is what this means, because we're bounded by all of the walls that connect each of the axes to each other. And then we have x equals 1, so that'll be a plane that's coming out a bit, which I guess I'll do it in a different color, so that it's a bit more visible. So we have a plane x equals 1, and then we have y plus z equals 2, which you can rewrite this as z equals 2 minus y. So that'll be like this right here. But you see, we have this like prism here. We have this triangle, we have a plane up here. Yeah, it's sort of like a ramp, like if you were going on like a skateboard, you have like this ramp. So, anyway, so we'll be using the divergence theorem here. So we'll just take the divergence of F. So to take the divergence of F, we will take so F is given by this guy right here, y squared z minus y and minus x squared y, where this is like p, q, and r. So this will be take dp dx plus dq dy plus dr dt. So in this case, p is going to be y squared z. So there's no x. So if you take the derivative with respect to x, you get 0. Minus y, it's pretty simple. You get minus 1. And then again, no z. So you get 0. So you'll see, because this question is quite contrived, we just get a constant as our answer. And it's suspicious how simple that number is. Because you'll see that if you were to plug that into this equation, you get the triple integral of minus 1 dv, which is just going to be minus the volume. But we know how to find the volume of a prism. I mean, you just take the length times the width times the height, and you divide by 2. So, in this case, the length of the prism, which, let's say the length is the distance in x, it's just going to be 1, because this is the x equals 1 plane.
So 4 over 2, negative.
The width is going to be 2, because you'll notice it's z equals 0, where you get y equals 2.
I'm smart to do it like that.
And the height is going to be 2, because if y equals 0, z is equal to 2. So minus volume is equal to minus, actually I may as well just write it fully out here. So the double integral of f dot ds equals to, in this case, minus the triple integral dv, which is minus v, minus 1/2 your length with height. So we just have 1 times 2 times 1 times 2.
The classic picture.
So you just get minus 2.
So embarrassing.
So you see the divergence theorem was really helpful here, because when we took the divergence of a vector field, we just got a constant.
Is the exam going to be this contrived?
Yes, I figured.
Yes.
All the exam questions are always like a little easier to do algebraically than all the ones in the homework in general.
That's mostly true. But because otherwise it would take too much time.
My only concern is we have 2 hours for this exam, so I think they're gonna like.
Bro, that's another thing. We have hella time.
Yeah, you'll have much more time per question.
I'm telling you, the news exam is about to be slayed, bro.
You
But
really?
Bro, I would not stress.
Okay.
I've seen all of them joints, bro. They're not hard.
Imagine he just decides to go.
Alright, well.
Yeah, he's gonna cook us on this one.
No, keep studying so you
Are there
No,
other
yeah.
questions before I go up there and erase that?
You said 15.
Yes. We've done 6.
I just need to remember that one.
Yeah.
Oh, that flame one?
7 of which will be multiple choice.
Well, I mean, yeah, she definitely
Forgot
knows
that
the exam's not.
magnitude didn't matter. It was only direction.
Which will be set the integral and go to that.
God damn it.
Bro, if you can set these those up, you're probably
He
fine.
was taking a picture.
Yeah,
Wait,
so if you could
Huh?
toss
Other
the
teacher creating
back
a
up for a second.
Yeah.
Are you on the
It was
Discord?
Gary's light input, I think.
Are you on the Discord?
Yeah.
I'm sending the full video.
Wait, you have?
Yeah, you said
Yeah, but I understand.
certain people might not have good data or bandwidth, so I'll
Good
post
po-
pictures.
Oh no, I'm gonna put it on YouTube. It's just a video.
Yeah, but some people might not be able to watch
for
it.
quick access.
Oh,
I'm
okay.
talking
Oh
like.
yeah, you're right. Sorry.
You'll be fine. Like, you can see this class, bro.
What?
You took a picture of 4 of us, what about the other 2?
Really?
I'll take a picture of that when I get there.
Oh
I
yeah.
was like, oh, honestly, please.
Oh, that's unfortunate. We for this for the American Institute of Chemical Engineers, there was like freshman class training, and we have a big freshman Discord for the freshman class, and we want to get all the chemical engineers. But we forgot to ask people for the Discord. Classic blunder.
For my
Yeah,
physics
I mean curvature, so just remember the formula for curvature. And yeah, so it's pretty much just we calculate our prime or double prime and then just plug it into the formula and we have the answer.
Wait, what's the derivative of the T again?
So you don't remember that formula.
Yeah. You ever see those memes where it's like it's a picture, you know, the chew guy memes, right? It's a picture of like E to the T with the chew guy head superimposed over it. It's like when they try and derive you, but you're just a chew guy.
Wait, you might not be able to.
So funny,
What a classic joke right there.
Unless there's like
When you can do a derivative, so you just like turn it,
you just have to like tee up.
shoot, that's so relatable.
Realistically, if you got the
Okay, so these like heavily contrived shit. This is what it's just like shaping up to be.
No.
It's like my high school. It's like my high school exams.
But I don't know if it's gonna be synthetic.
Is that right?
Yeah, they were just like controlled problems if you like really knew your stuff.
Yeah, I don't, because it's like a paper. I never laughed at that. Yeah.
And you probably didn't want to look like
Alright, so we found our prime, our double prime, we'll cross them and then we'll plug our prime on there and see what we get.
God bless.
Thank you.
What? That was crazy.
Next time.
Okay, so we cross them, we get this. You might be wondering how I did that without writing the
Oh, T
thing.
was 0, bro.
I just sort of looked at this guy, like this. Do the stuff.
I could have just evaluated that. God.
But you sort of see how you can sort of visualize.
Yeah,
so much
it's
easier.
much easier when you, I always do my project like that. That way I don't have to
Yeah.
do the whole entire table.
Exactly, but yeah, it's sort of like a visual trick.
I did the exact same
Yeah, so we
thing.
get this,
I'm going.
and yeah, we'll just take the length of the guy and stick it up there.
Yeah, that's stupid.
It's simple math, really. If you go do that in math, go do the math. I'm sorry.
Is that right?
Yes.
That EAS exam, when I went home after that. Did you actually? I was not staying here for 8 hours, bro. I knew if I went home, I was something. I said, I locked it. Guess what I didn't do? I didn't lock it or anything. No offense. I took a nice nap.
Locked in on that map.
I did. It was very nice. I'm trying to do wellness quotes because my business has
Mints.
Life is good.
You guys 33, that's crazy. It's probably pretty close to where I'm at.
Huh?
It's probably pretty close to where I'm at.
Yeah, like this is my last actual exam, and then after this, dude,
What do you have to get on
Should I
this?
do this problem?
Get in there.
like a 70. Not bad, like doable.
Like, as soon as I realized
That's
I
what you've
could
done the last
have
exam, so I'm getting
evaluated
that.
it, I kind of was just like,
Really?
you know what?
Yeah.
Never
But that's still doable.
That is
That's
very
fair.
doable,
If
yeah.
you really lock in, like
I am really locked in.
that's good.
All
Man.
this ever.
Honestly, I think the name of the game here is like you just can't fuck up on multiple choice.
Right.
His shit is heavy on multiple choice. You gotta know what you're
Oh, and
doing.
then, yeah, wait, no.
But he never does some other answers.
No, you did all that one
Yeah.
exam.
No, not Mr. Theory.
No, the second exam.
No, you're right.
No, we're talking about,
I'm
he's talking about Nate, the person who's making
right,
the
right,
exam.
yeah.
The person who wrote our exam. He doesn't do no type of.
He
Yeah,
never
that's like a
does any
goofy
other
ass
answer, that's good to
curvature.
know.
Yeah. That's as simple as it gets.
Yo, you know what?
Questions?
fail. You
Did anyone else get the same answer?
I got root 24 over root 5. Yeah.
You know what? Yeah, not much more to that one.
Yeah.
You got over root 5?
No, I got,
Root 5 cubed.
over root 5 cubed, but.
I think I'm locked in. I'm locked in.
Alright, so,
It's like, guys.
Very strange.
as some
This is
voices have alluded to, we will take the negative gradient
Voices. Go down.
to go down as fast as we can.
Yes. Alright.
Wait, what if we just respond with down?
See, this is
In
my
which
point.
direction should you walk to descend down the mountain most quickly? Down?
In which
If I
direction?
just
What?
raise the negative
Just down. Would you just put?
Yeah.
Technically, that's the answer.
Plus 2y to
The steepest part of
Dig a hole.
Yeah.
Oh, dig a hole. Diggy hole.
Oh shit, the entire thing.
Come on, man.
But if you dig through a mountain like you're effing Steve from Minecraft.
That'd be crazy.
Does it have to be a unit vector?
No.
Great.
Not for greedy.
Does
Yeah,
the
but it
answer
says in
have
which
to be an
actually,
actual
it still shows the
scale?
direction.
Yeah.
But
That's
that,
One question.
Ah,
Does the
no,
answer-
no, Owen. No, I think you're right. Because on the exam, you said that it didn't have to be unit vector, and then I know you're gonna pull up the answer key. Mooski took off points on. Fuck this class.
Minus 4, minus 10?
Bitch ass class. Bro, I got points off from the last exam for doing that shit, and I almost swung. Nah.
Oh, you mean parentheses instead of?
No,
Doesn't
I didn't take the unit vector.
didn't take
And
the
he
unit
told
vector.
me.
Oh, yeah.
It's an
Which
option.
direction?
Yeah, I lost points
That is
on
another
that.
answer.
Oh god, I'm doing both, and then if I see both in the answer, I'm asked. This is bullshit.
I don't know what to tell you.
I'll leave that.
Because it still tells direction. It just shows how much.
It's very. I mean, if you don't see the answer, just do a multiple.
It is.
Yeah.
It's not like that hard.
That's very
Also, you
fair.
could just put a
Because why
random
have
one.
we
There is a
always
one,
needed, like,
depending on
unit
the
vector
answers
for
provided.
direction,
There
but
is
then
a
all of a
1
sudden
in
niggas
20.
just
There's
decide,
either a
oh,
1 in
no,
20
the regular one's
chance.
cool. Like,
It's alright.
Actually,
It still tells direction.
so every
In
vector
which
does,
direction
though.
should you
Yeah.
walk
So
to
then if
descend
we
down the
include
mountain
that
most
way,
quickly?
we shouldn't have
Down.
done anything. Fuck a unit vector, bro.
That's true. It's too complicated.
Like,
It's too much. Sometimes. 116?
get me all right.
Yeah.
Divide everything by
I feel like giving actual
Wow,
hiking
that
advice to
off.
this question.
He's crazy.
Like, in which direction should you walk to descend the mountain
Bro,
most
he's
quickly?
not very good.
On the path that provide like signs to show you the right way to go.
Fuck them
You know what? You know what? You know what?
Fuck them.
Alright,
Wow.
don't even look at the question.
Like,
The
oh
question
my God.
I'll show you a picture.
It's
It's a
up.
weirdly shaped mountain. It could be that if this is the height on the plane,
I wonder how it is being a viewer of the Discord. They just hear us
You could be
just
here.
joking around.
hello, I'm your neighbor. That's minus 4, minus 10 or whatever. You could have to go up instead of
Or you can go 3-dimensional and then you just draw a straight line,
Oh,
which
that
is the
does
actual
suck.
proper descent.
What, bro? Nah, yeah.
That
Huh?
first, that first
Blame
question,
you. You're
the
the
first
one who
question for
started
the last
saying,
exam.
Oh, let's talk reality. Follow the signs.
This is
The first and the fifth. I
Make
didn't
me
draw
fucking
that right.
tweet.
So it's gonna have to be.
So it's essentially a free response with no partial credit. That's.
Well, that's a bit sad.
I love when that happens though.
Anyway,
Oh wait, so
we're gonna be drawing a
This
nice,
goes from
beautiful
0
picture
to
here,
2.
because you know we're in art class 101.
No. This question's free.
He's already done.
What you think
Until he tells you to write it in 8 different
so you're
versions.
Also
from
supposed
0
to
to y over
C.
2.
It's either A or
He
none.
tells you
Y
this and
goes
that
from
questions
0 to
after that. It's like, how do you do it in 8 different
Alright,
ways?
so first I just want to point a few things out. So if you
Oh, shoot, I-
look
I
at
think I got it.
B,
I got it.
you'll notice that one of the bounds is a variable.
Well, that's just not.
So it's definitely not that one,
Yeah, okay.
because you're not going to get a number as your answer.
Yeah, that makes sense.
So it's gonna be either A, C, or D, but we'll draw a picture here. So we have x goes from 0 to 1,
Imagine I drew it wrong.
and y goes from 2x.
As long as you
so I have to
breathe and
write that.
actually don't have other thoughts trying to like draw you away from actually paying attention.
Makes sense. Makes sense.
I'll take a peek at that in a second.
Y equals that. X equals that. You know what? It goes from.
Okay, so y goes from 2x to 2,
Y
so
equals. No, x equals y over 2. And then it goes from 0. Y goes from 0 to 2.
Y over 2 to 0.
And it's not even close.
Oh, I forgot I could do this.
I didn't even need to stare at. I just. I didn't like that. It's gonna be. Sorry, I'm too.
alright, so I've just
You're
started.
right. No, you're right. No, I'm liking this side of the line.
I was wrong, but I forgot where it is.
No, it's,
Yes.
Yes.
right.
No.
Wait, is it?
Alright, so
How can you have x then when you go to the
we have dy dx, we're gonna go to dx dy, so we'll have x bounded by functions of y.
It's just
It is.
You'll
an
see,
easier version. of
that's the
the
same thing as
example.
x equals y over 2.
I didn't see the,
So x will go from 0 to y over 2 as you go horizontally.
Wait, how much?
Which fits none of them.
Wait.
Yeah.
None of
So it's
these.
just none of them then.
Yeah.
What?
No way.
That's sinister.
No, that's actually diabolical. they did that twice in the same exam.
Yeah.
That's sketchy.
They did that twice in the same exam.
If you, I'll just write what it actually is, just for completion's sake. So we have y goes from 0 to 2, and x goes from 0 to y over 2.
dx dy.
This is hard.
Or actually.
Questions about this one? So the key is drawing the picture.
You're none of that.
You figured it out.
I think your duty part.
So, I didn't actually write the options. I have to write the options.
The options are pretty important.
Shoot picture here.
No, you're chill. On the volume, what sphere? Center at the origin.
Alright.
It's C.
So
It's C.
you gotta go all the way around, so theta goes from 0 to 2 pi. Which
Yeah, C
eliminates
is-
nothing, so we keep
C
going. B, you'll notice we'll start at pi over 4 and it'll go out. Sorry, it'll start at 0, it'll go down to pi over 4. So it's probably C. And then the radius will go from, well, 0 to 2 because it's sphere of radius 2. So it is C. And they did the spherical coordinates change of variables properly. You have rho squared sine phi because it's volume. So
So with this one, I'm just, because it's a sphere and then there's a cone in it, we need to know that like,
It's an ice cream.
this
you'll
cone.
notice that the cone's angled at pi over 4.
Because
Yeah, big.
If equals pi over 4.
Not even close to it. Well, the way you drew
Yeah,
it just doesn't
okay.
sound like
Could also
it.
do
Wait, so
Yeah,
it's
'cause, like,
wait,
arc is
it's
squared,
like
right?
this, in the sphere raised
R
to,
squared.
and above the,
R.
so it's like
E R E.
I thought it was
inside of the
gonna look
code.
like that.
Oh, I get what
Like
you mean.
E's inside of the code.
Yes. It is.
It's like a. It looks
It's
like
inside
a,
of the cone and then below the sphere.
It's like a snow cone.
So you have a sphere, then you have the cone.
Isn't
like
it
this.
not a
Just
snow
straight
cone,
up,
though?
just
It's
like a
a
snow cone.
The
You have
cone
like
starts in the center
And then I'd
of
have
the
to go back
sphere,
around
and then it
and
expands out.
redo everything.
It would sort of look like an ice cream cone.
Yeah.
Like you'd have triangle
That's what I'm
base,
saying.
and then
It's
you
like
have the bump at the top where the sphere is.
Yeah.
So a scoop of ice cream and
stuck it on the
bottom.
Him today.
Spiked it on the bottom. I'm locked, yeah.
Alright, so as, I like that. That was a nice emo you did there. So
Hell yeah, sure. Pick it up now.
Oh yeah. Yes, sir.
Alright, so C. Here.
I just realized this is looking at 0.
So you'll see that we have a vector line integral. This is like pdx plus qdy. PQ is a vector.
I use that kind of.
Partial
And-
with respect to x minus.
Why did they
Yeah,
not
so
write
you
2
can't
y
parameterize a
equals
vector
squared?
line integral to the scalar line integral because, well, I mean, yeah, it's not a scalar.
Where's the top
so-
half of the circle?
There's no way that it's A.
It's not C either.
You'll
Because there's a
notice that
if you
the
do the
region's
derivative
actually
on
not
either side,
closed.
it's
I was gonna say,
actually
is it-
easy as shit.
So we go from
Because the
1,
other one's
0 to
One's
minus
0 and the other one
0.
is 1.
Yeah.
You can't use one here.
PDX.
No, the other one is 2D. E. Or 2
No, you're doing the dx part, you do it with respect to y.
Yeah, so it's 2e to the x squared, yeah.
Oh shit.
You'll see that this is how it's closed.
I'm bugging. My fault. My fault. My fault.
Does everyone see this is
My
how it's
fault.
closed? We don't doesn't say to then go back.
So it is B.
So.
It's not
Are they- is it
conservative, so you can't
conservative?
vote.
We're eliminating them one by one. So it's not A, it's not D. Use the fundamental theorem of line integrals.
Oh my god.
It's not conservative.
I would have built
Yeah.
C, so it's gotta be
Because then
B.
you would get, yeah,
It's
yeah.
not closed. Okay.
Well, let's see if it is conservative. So that's P, that's Q. If you were to take the
4x.
Is that conservative?
Y.
Both are zero.
Bro, it's not conservative.
Does not matter.
Zero to 2e to the x squared.
Theorem of line integral.
Yeah.
First of all, there's no function that can
Exactly.
go into
Oh,
both
wait.
those.
I'm hedging B, you gotta be B.
It's B.
Yeah,
Let me
it's,
explain why it's not, okay? It's not to explain.
But it's not conservative.
Hold on, let me show you why.
Okay.
dq dx.
don't like half of these.
It's zero.
One of them has to be conservative. It has to be conservative.
Y
It's not zero.
is not zero. It's 2e
Oh,
to
I
the
believe
x
that.
squared.
What?
Not equal to 0.
Yes, bro. There's a little one.
This is a necessary
Oh, no,
condition
it
for it to be
is.
conservative. It doesn't satisfy the necessary condition, so it's not.
Indeed.
Why they didn't write
Horrible.
it
It's
as
heartbreaking.
why they didn't write it as 2y because x squared
So,
is beyond me, but
Because
still.
we've eliminated all but one of the answers, and there is no some other answer here, it has to be B.
Imagine if there was.
Process of elimination.
I told you, hey, imagine if there was. I had a feeling,
Right?
Some other
because I can never tell when it's
answer.
So I just, you know.
Isn't close just like a?
I think you can use
No.
Yeah. But like, I
Yes,
just,
are these
I
the
just
ones
can't tell.
like you find
Wait,
the
imagine if
position
somebody, when
vector,
they're writing a line, they just randomly
and then
throw
you
their
just take the like the times the x and the y and plug it in for
Then they
t.
just Well, they rip their paper. You just see everything.
Wait, sorry, so they-
So the position vector will give you like the cosine t, sine t, right? And
Oh,
then
right.
You just parameterize in terms of.
Oh, right, yes, you'd have like x equals
Yeah.
cosine t, y equals sine t. And then you do like f of r of t dollar prime.
Yeah.
Yeah, that's what you do.
dx is equal to x prime t.
And, yeah,
And dy is y prime t dt. That's what B
Yeah,
is.
yes.
Like, that's what you'd be doing.
yes, yep. Alright, but we won't be doing that because it doesn't say to do it, so we won't.
Yeah.
Version of the, some other answer,
No.
not valid.
I'm playing. Yeah, what?
Sequel.
Get that BS out of here.
Alright,
Get it out.
so, we will have to
You're not gonna
find the
evaluate
potential
this.
field,
Why not?
little f.
Technically, you could just do it in your head and write the answer, but you're gonna get points off of that.
So we need a little f,
But it's multiple choice.
such that the gradient
have
of
to
it is
circle one.
equal
You have to circle the one that fits the
F.
vibe
Wait,
most.
what's the necessary?
here. Yeah.
Is it
So
partial view? Partial.
anyway, what we'll do is
There
we will
is
take
an f
this guy,
where the
integrate
gradient
this.
of f equals that.
It's,
Wait, am I tripping?
dq dx has to be equal to dp dy.
Oh wait,
Which is, that works too.
Bro said the you said the necessary condition. I'm just
Yeah.
saying the absolute.
Because no, I was thinking it's not valid, but it is. It is.
I know that's why I said, dang it, it's
Yeah, yeah.
it's conservative.
Yeah.
Damn it.
Actually, so stupid, I fucked up some fuck.
So.
I'm no hater.
When you know the theorems, you just hope every single question you bump into is not valid, so you don't have to do the work.
Facts. You just have to- Oh, it's not. Oh, it's conservative. It's
God bless.
Okay.
Free points.
Somebody screaming.
That was a trick.
That was my check.
I couldn't tell.
I could, it was
a whole lot.
Instead of it almost sounded like a chicken.
Oh, they need to oil these suits, bro.
Blow them up before the exam.
That's what it
They
sounded
sounded
like.
as rusty as as the Tin Man from the Wizard of Oz, bro. Like what the heck?
That's true, that's true. Have you calculated?
Minus.
If I do that, it's actually gonna probably create one of the loudest noises in this room.
I'd start crying if you did that. That's what happened.
Minus negative 12. Minus 12.
Alright, so, everyone see how we found little f here? Are there questions about that? Alright.
What the heck kind of laugh was
So now we just take
Let the
the
loser impression.
f of that guy minus f of the other guy.
that?
Tapped out.
Huh.
That's a rhyme. Where's the whiteboard then? Please stop.
He's tired.
But he tapped out.
Y'all are not really-
Wait, where's our exam?
13.
IT 102. Yeah.
Yeah. 102. Wait, what?
Information tech. Wait.
Oh, yeah.
Information technology? I finally get to see what that looks like.
I've been in that building a
You haven't
concerning
been in
amount of
there?
times.
Nah.
What's your major?
What? Chemie. I don't have NS. I don't have
Chemie?
NS.
You're Chemie too, aren't you?
Mhm.
Wow.
You guys are soldiers.
Would you Kimmy's not have to take any S1?
We do.
We
He's just
do.
taking it
I
next
couldn't-
semester.
I'm taking it next semester.
What's your major?
Chemie.
Focus, focus, you've lost your focus.
Did you get
You
negative?
dodged the worst semester of ENES ever.
No.
That's kind of
This was the
You
worst
dodged
semester
the
of
worst
ENES.
semester of ENES ever.
Okay, great.
Why do you,
No.
why?
Bro, I can't.
I got
even explain.
I got negative 27.
What happened that's like.
That's
negative?
none of
They had to make it down bad. They made 2/3 of the semester.
Wait, crazy. It's not that. Wait, maybe I did.
I did not in the Euros project, like
I got negative
they
15.
look they look at me and tell me they have to make the
No, I did get that F, I'm honest.
Okay, maybe I added. So wait.
Never done shit.
Oh, he got minus 13.
Huh?
No. I got minus 13.
Oh, should this be a plus?
What major?
Oh,
Computer science.
I need to sign.
Oh, okay. Well, I switched my bounds, so.
No. I'm ready. Give me the exam.
Bro flips to the last page and does the last one.
Can we just do the exam now?
No, bro.
And Owen
bro.
grades it.
No.
That would be nice.
That would be very nice.
Give us all
By the grace of God, will that happen? But I doubt that's gonna happen. Kind of like how the world is like created against lefties.
Alright. That's it.
Because lefties are wrong.
Yo.
Yo.
Just because you're right doesn't mean you just
It's not
say
left,
it.
it's not left-handed, it's wrong.
Bro, that applies both.
You matter,
Work for
Oh, wait, you already did it.
I was.
Oh, yeah, I think you should use diversity.
I was saying
Just more
use
direct.
it's different than. Okay, I get what you're saying. Yeah.
It's C.
You
Oh,
Stokes.
because the vector surface integral would be.
D.
Alright, let's do this out.
Oh, shit. You know, that's actually.
Bro, you sounded like Patrick Star with that line.
Actually, D is technically doable.
equals 1
If it's-
Bro, no. I'm not
No.
It is the normal of that.
Yeah, I don't know.
D's doable, but it doesn't even get you like.
You can
It
use.
was-
It doesn't evaluate that.
Yeah,
That's
it
not
was,
appropriate.
It's like.
So it's not doable.
Like it's doable, but it doesn't even answer the question.
It's not.
It's not appropriate. That's not appropriate. That's
Now
not.
noted for the divergence theorem, we need f dot ds, not the curl of f dot ds. So if you wanted to use the divergence theorem, you'd have to find the inverse curl.
What the hell is that?
We're not doing that.
It was done the other
What
day.
is the inverse curl?
He's gonna
That's
ask us that on the
crazy.
final.
Hell yeah. I want to know more.
Find the inverse
What you really want to do is leave here and go
Anyway,
home
so,
and never
yeah.
talk about Calc 3 ever again.
Hell yeah.
Yes.
Yes.
We're not using this.
Hell no.
So we have, this is a vector, so we're not doing it as a scalar surface integral, that just doesn't even make any sense.
Ah.
No one was thinking to do that.
Ah.
Yeah. But Stokes' theorem, however, we could use because we could just take the boundary of the intersection of those regions and take f dot dr. Isn't that crazy?
He did it. He did it.
Oh my god.
That's great.
Bro, he did Stokes' theorem.
Oh my god. C is a really good option for Stokes' theorem because you
So that's it.
curl and curl starts with C.
That is the end of Owen's reviews. Thank you so much. I've enjoyed talking to you guys. We'll see you outside.